Okay, this is lesson 3 called equality. We're going to be examining what two things can make something equal. So it says shapes and patterns demonstrate relationships. If we look at the first two, it's saying that 2 squares are equal to 4 circles. So if I were to divide that in half, I would get 1 square equals 2 circles. Now, if we can continue it, I could make this even bigger. I could work backwards and I could go this way. What would 3 squares equal then? If I know 1 square equals 2, that means I would put 2 circles for each square. So how many circles would I have left over for 3 squares then? I would end up with 6. Okay, so each time for every square, they add 2 circles. That's what's going on. Each square adds 2 circles. So what if I said to you, I've got 5 squares? Okay, so if I have 5 squares, I need to continue the pattern. So I'm going to put 2 circles for each one. So what am I actually doing to the number?
7.
What am I actually doing to the digit? So if 1 is equal to 2, if I take 1 and multiply it by 2, I get my answer. So I can count them all, which would give me 10, but I could take 5 times 2 and get 10. So there's ways to create an equation. I could have said 5 times something gives me 10 circles. Okay? So 5 times what gives me 10 circles? 5 times 2. Okay? So that's how we create equations. So if we look at B, they're saying, well, 1 green rectangle is equal to 2 triangles. Well, if 1 is equal to 2 again, 2 would be equal to 4. And if I drew 3, again, what am I doing? I am adding 2 triangles for every rectangle. That's all we're doing. All right, turn your page. It says in a number of equations, the equal sign is the same as on a balance beam. We call it the fulcrum. So this thing right here that balances your balance beam, so kind of like a teeter-totter, it can go either way. That's what that thing is. It's called a fulcrum. Okay, that's your balance from the balance beam. All right, so it says here, the amount on both sides has to be equal in order to keep your level, in order to keep your, we could call it a teeter-totter, whatever you want to call it, your balance beam. In order to keep it from moving, you've got to contain the same amount on both sides. So there's the same amount on each side to keep the balance level. And when we keep a balance level, we say that we have solved the equation. Okay, we've balanced it and solved the equation. That's what's going on with that. Okay. All right. If I'm going to give you another equation, here's an example. If I've got 3 plus something equals 12, again, what is the missing number? Well, now we're starting to put letters for missing numbers. Instead of just leaving a blank, I'm now going to be using letters to represent that. So 3 plus what is 12? Well, what we're going to do is use the opposite operations. So we always use opposite. That's why there's lots of room on this page to write. That's why there's lots of room, because you're going to write what I'm writing on your page. We use opposite operations to move items across the equal sign. So you can kind of think of the equal sign as an electric fence. So the minute something moves over that electric fence, it gets zapped. And when you zap it, it does the opposite thing. Okay? Always think opposites. So if I want to move that 3 where the 12 is, I need to do the opposite. Right now, he's a positive 3. How can I get rid of a positive 3? We're going to do the opposite of plus. What is the opposite of plus? Subtract 3. Subtract 3. And now we add straight up and down. So watch what I'm doing and copy this down, please. Okay, so for our opposite operation, we add straight up and down now. So when I add these do what we call cancel, and they give us a 0. They cancel to 0. Well, if they cancel to 0, that means they disappear. We don't actually write the 0. That's what we want it to do. We want it to disappear on the one side and go to the other side. So now the 3's on the other side, and I have to add things up. So my X slides down. I'm going to add everything else up, and I end up with a 9. So now it tells me what my missing number is. So now if I rewrite it, if I rewrite my starting, I have 3 plus my X equals 12. If I put that number that I solved in the blank, if I put the number that I solved in the blank, I'm going to get a left side equals right side. So that means your equation is balanced. Your balance beam is exactly level, and that's what we want. So the left side equals the right side, so our equation is balanced. Okay? So that means your balance beam stays level. So your equation is balanced. Okay, turn your page. I'll give you a minute to finish writing that down, then turn your page. So now proving equality. This is where we want to check that the left side is equal to the right side of our equation. That's when we know that it's balanced. It's level and balanced. Okay, our fulcrum is level, and that's what we want for an equation. We want it balanced. So here it says we want to prove that this is true. Well, if you want to prove it, that means our equal sign, we put a little squiggly line down there, and we check our left side, and we check our right side. We have 6 times 4, we get 24. If I take 3 times 8, I get a 24. That means that it's true. So if my left side equals my right side, we say it is true. That's supposed to be an equal sign there. So let's take a look at B. Again, I'll put a little squiggle line down the equal sign, and we're checking to see if the left side equals the right side. So I would take my 5 times my 7, and I get a 35. On the right, I take my 10 times 3, and I'm going to get a 30. 35 is not equal to 30. So my left side here does not equal my right side. So when the left side does not equal the right side, that means it is not true. So your equation does not work. It's false. Okay? So you would draw the slash through the equal sign. That means it's not equal. Okay? So this is our not equal. Okay? So this means it is a false statement. It is not true. Okay? And like they're showing us, we use the not equal to sign. Okay? This concludes our lesson on equality.